Today we're going to do some exercises in parallel circuits. We've already learned that by definition, a parallel circuit is a circuit where there are multiple current paths. We also know that the voltage is the same everywhere in the circuit. However, in each path, the current will be different unless the resistors happen to be equal. But if we have unequal resistors, we will have different currents, and those currents will be inversely proportional to the resistance. In other words, higher resistance will have lower current, lower resistance will have higher current. We also have Kirchhoff's current law, which states that the sum of the currents through all of the branches will equal the total current leaving and entering the battery. And the total resistance is calculated using the product over sum or the reciprocal of the reciprocals method. Here is our first problem. We have 100 volts, 200 ohms, and another 200 ohms in parallel. What we need to find out are what is the total resistance, what is the current through R1, what is the current through R2, and what is the total current. Stop the video for a moment and solve the problem. Okay, so we have 200 ohms and 100 volts. We have that 100 volts everywhere in the circuit. So 200 divided into 100 is 0.5. So we have 1/2 of an amp flowing through R1. We also have the same situation here, 100 volts and 200 ohms, so we have 1/2 amp flowing through R2. So I have 1/2 amp and 1/2 amp. Kirchhoff's current law says that our total current must be the sum of these two currents. So what is our total current? It is going to be 1 amp. And of course, as we said, 1/2 an amp through each resistor. Total current is the sum of those two. Now what is our total resistance? Well, if we have two equal resistors, we know that the total resistance will be 1/2 of either of those. So two 200 ohm resistors in parallel will be equal to 100 ohms. Now we have 300 volts, 100 ohms, and 300 ohms. What we need to find out is the total resistance, current through R1, R2, and the total current, just like before. Go ahead and pause the video and work the problem. Okay, so what do we have? We have 300 volts and 100 ohms and 300 ohms. Well, this is kind of easy. 100 goes into 300 how many times? 3. That means we'll have 3 amps through the 100 ohm resistor. Here, R2 is 3 times the resistance. So if we have more resistance, we have less current. 3 times the resistance, we will have 1/3 of the current. So if we have 3 amps through 100 ohms, we must have 1 amp through 300 ohms. So our total current is going to be 3 plus 1, giving us 4 amps. So our total resistance is going to be 100 ohms in parallel with 300 ohms. So 100 times 300 divided by 100 plus 300 gives us a total of 75 ohms. Let's see if this works out. So if we have 75 ohms and divide that into 300 volts, we should get 4 amps, which we do. So this works. Let's try a similar one for practice. We have 400 volts, 50 ohms, and 200 ohms. So 200 ohms divided into 400 volts gives us 2 amps. So R2 has 2 amps through it. Here we have 1/4 the resistance, so we must have 4 times the current. So we must have 8 amps through the 50 ohm resistor, giving us a total of 10 amps. Let's check this out to make sure everything balances out as expected. So we have 50 ohms and 200 ohms. What's the total resistance? That will be 50 times 200 divided by 50 plus 200, giving us a total of 40 ohms. So 40 ohms divided into 400 volts gives us 10 amps. This one's a little different. We know we have 100 volts here. We have a total current of 600 milliamps. So I'm expressing my current in milliamps. 600 milliamps, or 600 1,000ths of an amp, is the same as 0.6 amps. So 0.6 of an amp. We have a 200 ohm resistor here, but we don't know the current, and we don't know what this resistor is. Do we have enough information to calculate this resistor? Stop the video and see if you can solve the problem. All right, let's see what we know. We have 200 ohms and 100 volts. So 200 divides into 100 gives us 0.5 amps, or 500 milliamps. So the current through R1 is 500 milliamps. Now for R2. So we have 600 milliamps. 500 of them go this way, so 100 milliamps must have gone this way. So the current through R2 is 100 milliamps. Now that we know the current, 100 milliamps, we can calculate the amount of resistance. We can calculate this out using Ohm's law, but before we do that, let's see if we can do it just using the rules for parallel circuits. If we have 1/5 of the current, we must have 5 times the resistance. So this must be 1,000 ohms. So R2 is 1,000 ohms. Let's confirm this with Ohm's law. We have 100 milliamps and 100 volts. So let's calculate the resistance. If you know your voltage, you divide into it. Be careful, this is milliamps, not amps. So 100 milliamps is how many amps? A tenth of an amp, or 0.1 amps. 0.1 amp goes into 100 1,000 times, confirming this resistance. We're transitioning into the kind of units we're using, so let's do another problem like that to make sure we understand. So now I have 20 volts, 6 milliamps of current. I don't know what R1 is, but I know that R2 is 10K. So let's figure out this circuit. We want to know the current through R1, the current through R2, and the value of R1. Go ahead and pause the video and solve the problem. So what we have here is 10,000 ohms and 20 volts. So 10,000 goes into 20, gives us an answer of 0.002 amps. Or we can say 10 kilo ohms divided into 20 volts gives us a current of 2 milliamps. So the current through R2 is 2 milliamps. Now we know that this is 2 milliamps. We start out with 6. 2 milliamps went this way, so the other 4 milliamps must have come through here. So we have 4 milliamps through R1. So we have twice the current, therefore we must have half the resistance. So R1 must be 5K. Let's confirm this with Ohm's law. 5,000 goes into 20 0.004 times, or 5 kilo ohms divided into 20 volts gives us an answer of 4 milliamps. And R1 we determined is 5K. Let's do one more problem like that. We have 30 volts, 5K. We don't know what R1 is, but we do have 9 milliamps flowing from the battery. So what is the current through R1, the current through R2, and what is the value of R1? Go ahead and pause the video and solve the problem. So we have 5K and 30 volts. So 5,000 goes into 30.006 times, giving us 6/1000ths of an amp, or 6 milliamps. Or we can say 5 kilo ohms divides into 30 volts to give us 6 milliamps. So the current through R2 is 6 milliamps. So we have a total of 9 milliamps. 6 milliamps went this way. So 9 milliamps come here, 6 milliamps went this way. The other 3 milliamps must have gone this way. So the current through R1 is going to be 3 milliamps. So we have half the current, so we must have twice the resistance. So if we have 5K here, this is twice the resistance, that will be 10K. Let's confirm that with Ohm's law. 10,000 goes into 30.003 times, or 3/1000ths of an amp. Or 10 kilo ohms divides into 30 volts to give us 3 milliamps. And we determined the value of R1 is 10K. Okay, here's a 3 resistor problem. We have 20 ohms, 10 ohms, and 20 ohms, and 40 volts. We need to calculate the total resistance, the current through each of the resistors, and the total current. Pause the video and solve the problem. Okay, let's calculate the total resistance first. And, well, we could calculate these two, 20 ohms and 10 ohms, but 20 ohms, 20 ohms. They don't have to be drawn next to each other. Just because they're drawn apart doesn't mean they're not still in parallel. So we still have 20 ohms in parallel with 20 ohms. So what is our resistance if we have two resistors of the same value in parallel? The total resistance is 1/2 of either of them. So this resistor, R1, in parallel with R3, 20 ohms in parallel with 20 ohms, is a total of 10 ohms. So R1 and R3 in parallel make 10 ohms. Now we have that in parallel with another 10 ohms, which gives us a total resistance of 5 ohms. So once again, 20 ohms in parallel with 20 ohms is 10 ohms. 10 ohms in parallel with 10 ohms is 5 ohms. So these three resistors together have a total resistance of 5 ohms. Now let's calculate our currents. We have 20 ohms and 40 volts. So 20 goes into 40. That's going to be 2 times. So we have 2 amps through R1. R1 is the same as R3. Voltage is the same everywhere. So same resistance, same voltage. We will also have 2 amps through R3. So R1 is 2 amps. R3 is 2 amps. R2 is half the resistance. Half the resistance, we get half the current, right? Careful. Half the resistance, we get twice the current. Lower resistance means more current. The current is inversely proportional. So if 20 ohms gives us 2 amps, 10 ohms will give us 4 amps. So the total resistance will be the sum of these. We have 2 amps, 4 amps, and 2 amps. It's a total of 8 amps. So we have 8 amps flowing through this circuit. 2 amps go this way, 4 amps go this way, 2 amps go this way, and then they all come back together to be 8 amps to go back to the battery. So that is our total. 5 ohms is our total resistance, and we have 2 amps, 4 amps, 2 amps, and 8 amps. Let's confirm this by dividing this resistance into our voltage to see if we get the right number of amps. So 5 ohms goes into 40 volts how many times? 8 times. So 5 goes into 40, 8 times, confirming we have 8 amps of current. So here's a similar problem just for practice. We have 60 volts, 60 ohms, 30 ohms, and 60 ohms. And we need to know What's the total resistance? What's the current through each resistor? And what's the total current? Pause the video and solve the problem. So what we have is 60 ohms and 60 volts. 60 ohms goes into 60 volts, gives us a current of 1 amp. And we have 60 ohms over here, so we have the same current, 1 amp. Here we have 30 ohms. Half the resistance, we will have twice the current. So we have 1 amp through 60 ohms. We're going to have 2 amps through 30 ohms. So we have 1 amp, 2 amps, and 1 amp. That gives us a total current of what? 4 amps. So we have 4 amps. 1 amp goes this way, 2 amps goes that way, 1 amp goes this way, then they all come back together to be 4 amps again. Let's calculate the total resistance and confirm that this works. This 60 ohm resistor is still in parallel with the 60 ohm resistor. So we can work those together. 60 ohms in parallel with 60 ohms gives us a total of 30 ohms between them. Now we have that 30 ohms in parallel with this 30 ohms, giving us a total of 15 ohms. So our total resistance is 15 ohms. So how many times does 15 go into 60? 4, giving us 4 amps of current. In this problem, we have 3 resistors in parallel. We don't know the voltage, but we do know the current through one of the resistors. We have 10K, 20K, and 30K, and what we want to calculate are the total resistance. We already know the current through R1, but we need the current through R2, the current through R3, and the total current. Pause the video and solve the problem. First, let's look and find where we have enough information to calculate something. And here we have that here. We have 10K and 6 milliamps. So we can calculate the voltage across this resistor, and once we do that, we have the voltage everywhere in the circuit, because being a parallel circuit, the voltage is the same everywhere. So we have 10K and 6 milliamps. If you don't know your voltage, you multiply. So we multiply 10,000 ohms times 0.006 amps, and that will give us 60 volts. Or we can look at it this way. We have 10K and 6 milliamps. If we multiply 10 kilo ohms by 6 milliamps, that will give us an answer in whole volts. So 6 times 10 is 60. Now that we know the voltage, we can calculate the current through R2. But let's not do it that way. Let's look at the rules for parallel circuits, and we see that we have twice the resistance. So we know that if we have twice the resistance, we will have half the current. So that must be 3 milliamps. And here we have 3 times the resistance, so we must have 1/3 of the current. And now we can find the total current by adding these together. 6 plus 3 plus 2 is 11 milliamps. Now let's find the total resistance. And this time, let's use the reciprocal method instead of the product over sum. So we're going to take the reciprocal of R1, add that to the reciprocal of R2, add that to the reciprocal of R3, which will give us an intermediate number, and we take the reciprocal of that number, and the result is our total resistance. Instead of using 10,000, 20,000, and 30,000 ohms, let's remove the thousands, and it'll make the calculations a little easier. We just have to keep track of our units and remember that our result will be in thousands of ohms, not in direct ohms. Let's see what that does. So we're going to take the reciprocal of 10 plus the reciprocal of 20 plus the reciprocal of 30. We'll add these numbers together to get our intermediate number. Now we take the reciprocal of that and we get an answer of 5.45. Remember, this is 5.45 K. So our total resistance is 5.45 K. Now that we have that, we can confirm that these numbers work out. So if this is correct, if we divide 5.45 K into 60 volts, we should get 11 milliamps. So 5.45 K into 60 volts equals 11. Here's a similar problem. We don't know the battery voltage, but we do have our resistances, and we know our current through R1, which is 3 milliamps. We want our total resistance, current through R2, current through R3, and our total current. Pause the video and solve the problem. Once again, we have our resistance and our current, so we can calculate the voltage, and of course the voltage is the same everywhere. So 30,000 volts and 3 milliamps. If you don't know your voltage, you multiply. So that's going to be 3 times 30 gives us 90. So 3 milliamps times 30 kilo ohms gives us 90 volts. Or on the calculator, 3 milliamps, 0.003 amps times 30,000 gives us 90. R2 is 1.5 times the value of R1. So that means that the current must be 2/3 of the current. So higher resistance means less current. So 1.5 times the resistance means 2/3 of the current. So this must be 2 milliamps. And we can confirm that with Ohm's law. 45 K into 90 volts gives us 2 milliamps. So it does work. And 90 K is 3 times 30 K. So if we have 3 times the resistance, we must have 1/3 of the current. So 3 times the resistance, we must have 1/3 of the current. So this must be 1 milliamp. And our total current will be 3 plus 2 plus 1, or 6 milliamps. Let's calculate the total resistance and confirm that 90 volts divided by that resistance will give us 6 milliamps. So we have the reciprocal of 30 plus the reciprocal of 45 plus the reciprocal of 90. Add those together, take the reciprocal of that, and we get 15 K for our total resistance. 15 K dividing into 90 volts gives us 6 milliamps. In this problem, we know the total current and we know the voltage, but we want to know the total resistance, the current through the 3 resistors, and in this case, the value of R3. Pause the video and solve the problem. Okay, we have a total of 26 milliamps to work with. Let's see how it's distributed and find out what we have going on in this branch over here. We have 50,000 ohms and 100 volts. So 50 kilo ohms into 100 volts gives us 2 milliamps. Now we have half the resistance, so we must have twice the current. So this must have 4 milliamps. So here we have 4 milliamps and 2 milliamps. That must be 6 milliamps total. So we have 26 milliamps coming through here. 2 milliamps go this way, 4 milliamps go that way. So what's left to go this way is 20 milliamps. So now we know the current through R3, and we see that R3 has 10 times the current of R1, therefore it must have 1/10 of the resistance. So 10 times the current must be 1/10 of the resistance, so it's got to be 5 K. So here's our currents: 2 milliamps, 4 milliamps, and 20 milliamps. What's the total resistance? 1 over 50 plus 1 over 25 plus 1 over 5. Take the reciprocal of that, and we get a total of 3.84 K. .84K divided into 100 volts gives us, considering rounding errors, 26 milliamps. If you found this video useful and informative, please give me a thumbs up down below. It really helps the channel. And subscribe, because that not only informs you when I put new videos up, but it really helps the channel also. And a big thank you to my patrons at Patreon. I could not make these videos without your support. If you want to help me put these videos online and keep real vocational education free at vocademy.net, you can go to patreon.com/join/vocademy and pledge your support. And again, a big thank you to my patrons who make this possible, and a big thank you to everyone for watching.